Assalamu alaikum. Dears all, today we will continue and cover the chapter Economical Functions, Elasticity and Revenue. Let us start by studying the relation between revenue and the elasticity of the demand. In the figure to the right, the abscissa axis corresponds to the price P and the ordinate axis to the revenue R. First, if the demand is elastic at P, then the revenue R of P decreases as the price P increases. As you shown in the figure, the revenue function is decreases as the price P increases. That means elastic demand R prime of P less than 0. Also, the revenue is decreasing yields that the demand is elastic, hence E of P greater than 1. Second, if the demand is inelastic at P, then the revenue R of P increases as the price P increases. As you shown, the revenue function increases as the price P increases. Hence, inelastic demands yields that R prime of P greater than 0. Thus, the revenue is increasing. That means the demand is inelastic, or E of P less than 1. Finally, if the demand has unit elasticity at P, then the revenue R of P is maximum at P. Thus, the unit elasticity is attained when R prime of P equal to 0. Hence, in this case, we have a maximum revenue. That means E of P equal to 1. Now, example 1. An enterprise produces a certain type of objects. The daily demand is modeled as D of x equal 2 into x minus 1 into E minus 0.5x, expressed in thousands of kilograms, where x is the unit price expressed in thousands Lebanese Lira, and x belongs to the global interval 1-5. Part 1. Calculate the number of demanded objects for a unit price of 2000 Lebanese Lira. In this part, we know x, and we need to find d of x. So x equal 2000 divided by 1000. We get 2. Then we replace 2 in the demand function d of x. And we get d of 2 equal 2e power minus 1, which is approximately equal to 0.7358. Thus, the number of demanded objects for a unit price 2000 Lebanese Lira is 0.736 times 1000. So we get 736 objects. 2. Part A. Calculate the elasticity of the demand E of x. First, we find d prime of x, which is the derivative of the demand function d of x. So d prime of x equal 3 minus x into e power minus 0.5x. Then we write the rule of elasticity of the demand. E of x equal minus x d prime of x over d of x, which is equal to minus x into 3 minus x e power minus 0.5x all over 2 into x minus 1 into e minus 0.5x. E power minus 0.5x is cancelled out in both sides of a fraction. Then we simplify it and we get E of x equal x squared minus 3x over 2x minus 2. Part B. Calculate x, for which E of x equal to 1. In order to find x, we need to solve the equation E of x equal to 1. So Ex equal to 1 equivalent to say that x squared minus 3x over 2x minus 2 equal to 1. And this yields that x squared minus 5x plus 2 equal to 0, which is a second degree equation. And using calculator, we solve this equation, and we get x approximately equal to 4.562, or x approximately equal to 0.438. But x belong to the interval 1, 5. Hence, 4.562 is accepted value while 0.438 is rejected. Part C. Deduce the unit price when the revenue is maximal. Please pay attention. The revenue is maximal when the demand is unit elasticity. That means E of x equal to 1. And this equation is solved in the previous part. Hence, the solution is x equal 4.562. Thus, the revenue is maximal at a unit price 4,562 Lebanese Lira. Here, we answer the question by multiplying the value of x by its unit. 3. Part A. Determine the revenue function R of x and justify that it is expressed in millions Lebanese Lira. So in this part, we need to determine R of x. First, we write the rule of the revenue function. R of x equal x times d of x, price per unit times demanded quantity. After that, we replace the expression of d of x, and we expand it with x. So we get R of x equal 2x squared minus 2x into e minus 0.5x. Also, in this part, we want to justify that the revenue function R of x is expressed in millions of Lebanese Lira. We know that the unit price x is expressed in 1,000 Lebanese Lira and the demand function d of x in 1,000 kilogram. Then R of x is expressed in 1 million Lebanese Lira. Part B. Calculate R prime of x and deduce again the unit for which R of x is maximum. The demand function R of x is obtained in the previous part. So we calculate the derivative of R of x, and we get R prime of x equal minus x squared plus 5x minus 2 into e minus 0.5x. Also, to find its maximum, we solve the equation R prime of x equal to 0. We get x approximately equal to 4.562, or x approximately equal to 0.438. 4.562 is accepted, since it is belong to the interval 1, 5, while 0.438 is rejected. The answer is true, same as we found in the previous part, when we solve the equation E of x equal to 1. The last part in this example is calculate the maximum revenue. In this part, we need to calculate the maximum revenue. Here, we know the unit price x, when the revenue function R of x is maximum. So x equal to 4.562. Now, we replace 4.562 in the revenue function. Then we get R of 4.562 approximately equal to 3.321. Therefore, the maximum revenue is 3.321 times 1 million, which is equal to 3,321,000 Lebanese Lira. Application 1. A company produces batteries. The demand function expressed in thousands of batteries is given as f of x equal 2x plus 6 into e minus x, where x is the unit price expressed in 1,000 Lebanese Lira. X is bounded between 0.1 and 4. Please pay attention. The unit of the unit price x is 1,000 Lebanese Lira, and the unit of the demand function d of x is 1,000 of batteries. I need from you to solve parts 1, 2, and 3 in your own, then to check your answers. Finally, part 4. The table at right represents the variations of R. A. copy and complete the table and calculate the maximum revenue. First, we find R of 0.1 by replacing 0.1 in the expression of R of x. Then we get R of 0.1 approximately equal to 0.56. Also, in the same way, we find R of 1.303 approximately equal to 3.047 and R of 4 approximately equal to 1.026. Pay attention. Using the table of variations of R, we find that the maximum revenue is 3.047 times 1 million, which is the unit of R of x. So the maximum revenue is 3,047,000 Lebanese Lira. B. How many demanded batteries correspond to this maximum revenue? In this part, we need to find the demand that corresponds to the maximum revenue. First, we find the price for which the maximum revenue is attained. Hence, the maximum revenue is attained at x equal to 1.303. Then we replace this price in the demand function f of x, and we get f of 1.303 equal to 2.338. Hence, the demanded batteries corresponds to the maximum revenue is 2.338 times 1000, which is equal to 2338 batteries.